Hello students. In the part 4 we were completing the part where we were discussing the Einstein's theory of relativity, which was special theory. Okay, so one thing that was remaining was that Einstein said that time is relative, means that it was dilating. Dilating means it was slowing down, and slowing down for the person or object moving at high speeds. Okay, so very important that time is relative. Time is relative, but the speed of light is constant. Okay, so very important to understand this relationship. Okay, so it was dilating for the person, object or object moving at high speeds. Whenever you move at high speeds, or even or moved close to heavy or massive objects, that happens, and vice versa. That means if you are moving slow, then as compared to the high speed person, the time will be slow for you. Time will be moving faster for you. But in case of there is a faster movement, for example, a person moving through space, he may be moving with the very high speed from one planet to another, and that's how he will be, like, for him, that person, the time will be slower. He will still be younger when he'll come back, but person or his family relatives who are on the earth will be aged, because at that place time is moving faster. So that depends on the object or person who is moving based on the particular reference. Okay, and vice versa, as I very well know. Okay, now let us move to the second theory, Einstein's general theory of relativity. General theory. In this theory, he included gravity and interpreted gravity. In gravity, he gave new interpretation. Second, he applied this particular theory to massive objects. Now, this theory says that space and time are part of the same dynamic called the space-time framework or matrix which is nothing but the gravity itself. So space-time are interacting in the gravitational space, and gravity itself, what does it mean? Gravity is a curvature in space-time. Gravity is nothing but a curvature in space-time. Particularly near the massive objects. Why? Because massive objects have huge gravity. But gravity as a from Newtonian perspective is about attraction between two masses. However, Einstein said that gravity is not an attraction but actually a curvature in space-time fabric or framework. Okay, and it is a homogeneous fabric flowing in the space. So space is not empty, it is a space-time fabric itself. And what he says, there are curvatures in the fabric. You can see this diagram. Maybe this is a big object, possibly a big planet like Jupiter, possibly. And near the Jupiter there is huge gravity. But Einstein explains that the light, even the light that is moving, will be moving around it. It will be bending. As we very well know that there is no bending of light possible in general. It moves in straight line. But around the particular high gravity situation, it bends. Okay, so it bends and moves around it. Similarly, we saw the bending of light near the black holes also. Okay, black holes which are not visible in general, but you see whenever there is a light, it is moving around it and going inside it, and there is no coming out of that light. It is only visible at the horizon part, which is the horizon, the outer layer of the black holes. Okay, so very important is this theory of general relativity. So I hope this part is very clear and it will help you understand the modern advances in the space technology, space exploration and various other aspects through these lectures. Thank you very much.